I'm no, not an anarchist, because I believe in private property, and you know that's the difference between an anarchist and a pure libertarian. Actually, I'm an anarcho-capitalist, paleo-conservative libertarian. That describes my...
You left out born again.
Yeah, no, I don't have much time at all for politics as usual on either side of the so-called political spectrum. My direction is not left or right, it's up and out. That's the direction I'm.
Well, let's make the spaceship.
All right, well, one of the things that I plan to do is, if I have, a week or two over the holidays, I've got lots of really cool new material that I don't want to just like throw you a barrage of a lot of different things. So I want to get it at least somewhat organized in a systematic fashion. But the thing I'm probably most excited about is this astronomy software I've been learning. So it's going to soon, when we do in January, I'll be incorporating, animations of sky motion, and really, it's really going to add a whole other dimension to our discussions about, the cosmic or the astronomical component of all of this, because that's becoming more and more important, and becoming more and more relevant. The more we learn about what's here below, the more we realize that what's going out there above is translating down to here below.
You can take it back 2,000, 10,000 years.
Oh, I can take it forward or back like 1,000,000 years.
That's what
So it's going to cover.
I've heard of that software. I'd like to.
Yeah. Oh, I've got my list of, we're going to do, making a cool star map of what happened July 4th, 1776. So you can see what was going on that day, and astronomically something very interesting was going on. It tracks comet motion, it tracks, meteor motion, asteroids. You can demonstrate the great year with it, the precession of the equinoxes. Yeah, it's really good.
Just remember what the name of it is.
It'll come back to me. Voyager, like the Voyager. Yeah.
Voyager 4.5.
Yeah, it's the Voyager, but 4.5 is the latest version of it.
Okay.
And I don't have a telescope, but it will run it's probably not the best software if you're going to be running a telescope off of it. It will.
Okay, good.
But it's probably not the best for that purpose. But that's not going to be my main use of it. Would be archaeo-astronomy, going back, because now with this, you can just basically tell it any time of day, any time of year, any point on the Earth's surface, and you can create, maps, celestial maps in 4 different coordinate systems and 5 or 6 different map projections. So it's really, really going to be a fun thing, and I'm going to be able to bring a whole new dimension of stuff into this, which I'm really looking forward to. Thanks to Brad, we have this, which I wanted to show you. Well, what this does, this is probably the most detailed world map now available outside of classified circles. And of course, with this smaller version, you can't see, but this is probably not the highest resolution that you gave me, is it? Yeah, you can get this much higher resolution, but the good thing about this is what I've done with it. I've taken this map, which shows the present-day coastlines, and watch carefully. You'll see what's going on here. This is sea level during the last ice age. Oops. So here is North America at present, and you can see the coastal shelves, and now we can drop the sea level 400 feet to what it was during the glacial maximum. That's pretty impressive, isn't it? That really conveys how dramatically the coastlines of the world have changed. Like, watch this area up in here. And of course, what's missing from this, which I'm going to do a graphic of, is, this is, right here would not be correct, because when sea level was at that down 400 feet, of course, this wasn't green up here, was it? That was a massive ice sheet.
And Atlantis, that would be...
Well, let's try something here. Okay, now on this one, watch. You see Alaska up here. Now watch, and you can get this is the lost land of Beringia.
Wow.
Okay. So if you want to talk about sunken lands, there's a bona fide, scientifically accepted sunken land right there. All of this area, and you can actually look, there's more land now that was part of Beringia under the ocean than the size of Alaska. And of course, when you're over here, you're now in Siberia. So this was a whole big traffic way for animals and people and everything coming across. Now, let's see what. Down around what? Malaysia. Okay, well, here we go. This is down around Malaysia. This is what Jerry just was asking. You can see Australia there and India, and here's what do you call that? I mean, the whole...
South Vietnam.
Well, yeah, this is South Vietnam. What's the whole peninsula called? Includes Cambodia, Thailand. Indochina, that's what I was looking for. Yeah, thanks. That's Indochina. And this here, I believe, is Sumatra. Right there. Yeah. So here, this is now, and here is during the Ice Age. Yeah, so you can see there's a whole drowned land in here as well. Let's see, look all up in here at all of this. I mean, there is a lot of land exposed during the Ice Age that's now underwater, and that's why I've said for years and years and years now, I think that the future of really archaeology is going to be marine archaeology. I mean, we're going to be discovering things, off the coastlines, because during the Ice Age, this is where people would have been living, down near sea level.
How deep is it now? A couple hundred, or what do you...
Well, at the deepest, I mean, it goes from 0 at the current coastline to as deep as 400 feet. Not counting tectonic movements. Just counting the rise and fall of sea level itself.
No, they're going to have to do it with submarines to dig up artifacts.
Yeah, I don't know what would be the best way to excavate or examine something to say 300 feet underwater. Would you use a submarine for that, or some kind of a submersible?
They've got some submergibles now that's got...
I mean, that's not that deep, 300 feet. It's too deep for a scuba diver.
Now, there's something else now. Off the east coast of the United States, the continental shelf, at the edge of the continental shelf is 600 feet.
Yes, and if we go back to here, you'll notice that you can see very clearly here the continental shelf outlined in light blue, but when we show the coastline, you'll see there that the coastline doesn't exactly conform to the continental shelf. Yep. So, like up here, the continental shelf would have been 400 feet, but down here where you're talking about, yeah, it's probably 600 feet deep there. So you're still a couple of hundred feet underwater here, even during the Ice Age. Yeah, the whole coastal shelves weren't exposed, but most of them were, as you can see just by looking at these graphics here. And let's go to...
How far did the ice go? I mean, how much of that was populated by people, like Florida and...
Yeah, Florida was populated.
And it started to wean out when you got up to Illinois or maybe Tennessee?
Well, there were people living right up on the edge of the ice sheet. Right up until the big destruction, there were people living right there.
Where would you say the edges?
Well, I'll show you on another graphic coming up.
Can you show the Straits of Bosporus?
I think so.
Let's go north now.
Right.
Straight north.
That would be right in here you're talking about, separating the Mediterranean from the Black Sea. And what Sam is getting to is that during the Ice Age, what is now the Black Sea, which is connected to the Mediterranean, which is connected to the Atlantic, the Black Sea was an isolated freshwater lake. And then the sea level rose, say the 400 feet, and there was a sedimentary plug separating the Black Sea from the Mediterranean, and somewhere between 7,000 and 8,000 years ago that gave way, probably as the result of some earthquake or some catastrophe caused that to give way, and the water flow that came in there was equivalent to 200 Niagara Falls, and it brought the level of the Black Sea up 400 feet. And there's some scientists that have studied that think that's the origin of Noah's flood. But remember, Plato reported that the Egyptians said that there were numerous great flood catastrophes, and why they were so obviously superior to the Greeks was the Greeks only remembered one of them, and they remembered at least 3. So, when you put all that together, we're probably looking at a great flood at the end of the last ice age. We're probably looking at a great flood associated with the Burckle crater event in the Indian Ocean. We're looking at another great flood. I mean, the one overriding thing that really, when you start looking at this new paradigm of history, is that catastrophe almost seems to be uniformitarian, in that there have been so many catastrophes of such incredible power, and it's only in our own time. Our own time is exceptional in that not much has happened in the last 300 or 400 years. The last global event was the transition from the medieval warm to the Little Ice Age. And that wasn't catastrophic in the sense that, it instantly annihilated cultures or caused mass extinctions. But it was catastrophic over like a generation, because the population of Europe, as the result of going into the Little Ice Age, ended up only being 2/3 of the population of Europe died as a result of the onset of the Little Ice Age. Ultimately, see, and it wasn't straight out like being killed in an asteroid impact kind of thing, but it was succumbing to starvation. It was succumbing to the disease that followed in the wake of the malnourishment, the opportunity, we've talked about that, the opportunistic diseases, the bubonic plague and black plague that came along and were able to exploit the weakened immune systems of people and essentially decimated the population. And that was all, maybe not the direct result, but was certainly tied in, was an indirect result of the change in climate. So in a sense, it was a catastrophic effect, and that is now being attributed, by a whole group of scientists that have been studying it to an influx of cosmic dust and possibly even an impact that has as of yet gone unrecognized. And then, of course, there was the catastrophe of 540 AD, which seems to have be tied in with the whole Arthurian mythos, with the onset of the Dark Ages, and the onset. This is where the whole idea of the wasteland came out of this 540 AD event, where Northern Europe was essentially just rendered, was decimated for about 50 years.
Well, when did Santorini?
Santorini was, and that was, that was certainly a regional catastrophe. It wasn't a global catastrophe.
900 years before Plato, because everybody thought we had it.
Well, that would have been it. So 900 years before Plato, or 900 years before Solon. So Solon was 500 BC. So closer to 1500 BC then is when it was. Yes. Okay, so now on this one, take a look at Europe. You'll see Scandinavia, and here's England, and here's Ireland, right? So when we go to the Ice Age, you can see there were no British Isles. There was no Baltic Sea. And in fact, this is Iceland right here. Yeah, you can see Iceland was much bigger.
Little changes around Africa.
Yeah, not that many changes around Africa because, well, it's all a function of how wide the continental shelf is. So around Africa, there's not a wide continental shelf, and so Africa's coastline didn't change a whole lot. But around Africa, the water would have gotten really deep really fast. Now, during the Ice Age, this whole area, like what is now the North Sea, right up here, this was a vast fertile savanna populated by herds of woolly mammoths and camels and, pardon? Yeah.
There's little islands off the coast there too that are the triangle.
Yeah, look at that. Right here, there are islands that show up that aren't there now. So there you go. There's some sunken islands right there.
That won't be Atlantis, though, would it?
Well, remember Atlantis was said to be west of this point.
They had outposts. Would it have been warmer?
Sure? No, it would have been cold. Well, where is Atlantis on here? Who can find Atlantis? Somebody walk up there and put their finger on Atlantis.
Yeah.
That would be where I'd put my money, right there, for a lot of reasons. And if
There's a beautiful set of islands right there called the Azores.
Yeah.
Been all over them. And there's something else.
let's see here.
I think we should have a trip and rent a submarine.
Well, you start raising the funds. That's the only thing between us and doing it is. No, they don't show Atlantis on there. They don't. But clearly, I'm trying to see here if they do show the islands being bigger. No, they don't really, I bet. Okay, Elizabeth, you asked about the extent of the ice sheet. So let's look at this. Okay, so here's now, and here.
So it didn't go over in Asia at all?
No, what northern, see that's northern Asia. Now you see right here is where, watch. Okay, you see,
Scandinavia.
yeah, here's Scandinavia and here's the British Isles. Okay, keep your eyes on that. Scandinavia, the British Isles. So they're covered with ice, yes, they're covered with ice. And in fact, one of the things I brought in 2 weeks ago, or 4 weeks ago, was the flood, the glacier flood that came down through here and cut the English Channel. Which would have been coming right off, it would have been flowing right down through here. You see that lowland? That flood would have come right down through here, just like the Missoula flood, and scoured these big channel scablands. However, unlike the Missoula flood, once the melting was over and sea level rose, it drowned those scablands that are now on the bottom of the English Channel.
Why didn't the ice go more on the other side too?
See, now that's an interesting question, because the center of mass of the ice cap is right here, which is over Hudson Bay. And I don't know.
Do you think that was the pole at the time?
Well, that's what some researchers think that.
Well, what do you think?
Well, I think it's very possible.
Okay. Well, then that would make sense.
Charles Hapgood wrote a book back in the 1950s called Earth Shifting Crust, revised in 1976 called Path of the Pole. And he amassed a whole body of evidence to show that during the Ice Age, the North Pole was not up here, it was down here where Hudson Bay now is. And it's interesting that if you take a map of the Earth and you draw a circle around the North Pole that coincides with the Arctic Circle, well, that circle, pretty much, a circle of that size, pretty much encompasses this ice sheet right here.
I've got a map that's got the last 4 positions of the North Pole over the last 450,000 years, and the last time it was in the Hudson Bay.
Who produced that map?
I don't know.
I mean, because that is not accepted by mainstream science.
I got it on my computer. I don't know who made it.
Well, it's probably Charles Hapgood. And I think in the end, Charles Hapgood might be shown to be right. Because, and we've talked about pole shift several times in here. And there was, the idea going around for many years, particularly going into the 80s and 90s, the idea that the catastrophe was going to be provoked by a pole shift. Remember that? And Richard Noone wrote his book, and it was all about a pole shift. And there was several others. Hugh A and Klaus Brown wrote a book in the 60s, I think, or 70s, that the Earth would flip, and that's what would cause the ice ages and so forth. But after having looked at the whole physics of it, I came to think that that was not a plausible mechanism, and you didn't need a pole shift to bring on that like an asteroid or a comet impact was far more likely culprit than a pole shift. However, that didn't take pole shift off the table, because if you begin to think it through, the shifting of the pole becomes a logical consequence of the process of shifting from a glacial age like that to an interglacial. Because you know that the Earth is bulged around the equator. It's oblate, right? Earth bulges this way, it shrinks this way. That's why there's a 26-mile difference between the equatorial diameter and the polar diameter. Well, as the Earth spins, there's an equilibrium between the position of the Earth's crust in terms of its latitude, north or south, and its distance from the Earth's center of gravity. Now, what happens if you remove that ice? What is the process that happens when you remove that load and the land starts coming back up? Or when you put the load on and the land starts going down? What's the word? Who remembers?
It's called out of balance in a tire wheel.
Yeah. Who's saying that? Isostatic adjustment. That's the word, isostatic. And it means if you're sitting on a soft cushion right now, on a chair, the cushion you're sitting on is isostatically depressed due to the weight of your ass. And if you take your ass, just think of think of that ice cap as being your ass sitting on the chair, and you'll get the concept. What do you call it? Isostatic adjustment, right. That's the way we...
I'm going to say something. Your website, far out.
Oh, really?
Very nice.
Thanks, Paul. It's getting better. Slow but sure. It's...
Back in the 50s.
Thank you. I appreciate
I
that.
would
50s,
suggest
early
everybody
60s.
look at his website.
2 books written, one called Worlds in Collision, one's in Worlds in Upheaval.
Velikovsky, yes.
Velikovsky.
And he proposed a
And
pole
he said
shift.
this same thing. He said there's been 175 pole shifts in the past. Since in the last 550 million years, there was 176. And he said there will be a new one sometime after the turn of the century. The shift would happen again.
Well,
You're talking reversals, not necessarily a shift.
No, he says pole shift. Now there is reversals too, but they don't have, the reversal only happens about every 40,000 years.
well, let's be clear on this, because in discussions on pole shifts over the years, I've noticed people are not clear on this. There's the magnetic pole and there is the geographic pole. The magnetic pole is where your compass points to, right? The geographic pole is the center of the Earth's spin, and they're not the same. They are not the same. Now, the magnetic pole does change, and it's been well documented that the magnetic pole can fluctuate, it can change strength, it can migrate around, it can actually reverse itself. But that is not the same as actually a geographic pole shift. Now, some of the theories of pole shift, the Hugh A Brown theory, for example, he was one of the most prominent proponents of a pole shift back in the 50s and 60s and 70s. He envisioned the entire mass of the Earth flipping over. Well, I think most geophysicists proved that that was an impossibility, that you couldn't even do that without the Earth completely disaggregating. Now, Charles Hapgood's theory was an evolution of that, in that he said, no, it was not the whole mass of the Earth that flipped. It was only the crust of the Earth that slid over the mantle. That actually makes a lot more sense than the earlier theory of the entire mass of the Earth shifting. But even to accomplish that, to shift the Earth's crust over the mantle, would require tremendous shear stresses into the crust, which actually may be, when you start looking at the rift zones and the uplifting of mountains and stuff, I cannot think of a better mechanism to accomplish the opening up that creates a vast rift zone, or the compression that pushes a mountain range up, than shifting of the tectonic plates over the mantle much more rapidly than would be allowed for within the theories of continental drift. But what Hapgood did was he proposed that something triggered the migration of the Earth's crust. What he proposed as the mechanism was that right there. He said an off-center, an eccentric ice mass, not balanced around the pole, would be enough to overcome the shear resistance between the bottom of the crust and the upper part of the mantle, and causing this slippage, a slide. Well, a number of geophysicists disputed that, and they said, well, even again, that doesn't make sense, because the forces necessary to break the crust loose and cause the whole crust, like the skin of an orange, say, being loose from the meat of the orange, being able to pivot around, even that is so extreme that this couldn't do it. And in his revision of his book in 1976, he puts in there as his preface, and he did this after communicating extensively with Albert Einstein about his theory. And Einstein gave a provisional endorsement to Hapgood's theory. But in his 1976 revision, he retracted the idea that the mechanism, the triggering mechanism, was the ice mass. Whereas that's what he was putting forward in his 1956 version. He retracted that idea 20 years later, right? Now then you had people like Richard Noone who came along and wrote a book, 552,000, in which he picks up on Hapgood's original idea that there was going to be a great pole shift on May 5th of the year 2000. And the trigger was going to be the growing ice mass, and in his book he documents the evidence from the 60s and 70s, which was accurate, which actually showed the Antarctic ice mass apparently growing, accumulating mass. And there was going to be a planetary alignment on May 5th of the year 2000. And what he proposed was that that planetary alignment was going to have enough gravitational effect that the already out of stable Earth was then going to cause to tip over because of the Antarctic ice mass. And the Antarctic ice mass would move up to the equator and then rapidly melt and cause a great catastrophe. And he bought land up in North Carolina and had a lot of people convinced that May 5th of the year 2000 was going to be when the shit hit the fan. But if you actually look at the physics of it, the idea never made sense in the first place. Because, and here's what you think about. You know that the gravitational effect of a mass is inversely proportional to the square of its distance. Well, that simple bit of Newtonian mechanics sort of got left out of the whole discussion. Because what that implies, and you can even just think about it. We go out to the ocean and we see the tides coming in and going out, right? And can be pretty profound. I mean, look what's going on over in Venice right now because of the highest tide they've had in a long time. That tide is 99.9% the result of the position of the moon and where the moon is relative to the Earth. Now, the moon has a perigee and an apogee that varies from 221,000 miles from the Earth to 252,000, right? Now, that difference between the moon's closest position and farthest position has thousands of times more gravitational effect on the planet than a planetary alignment, hundreds of millions of miles away.
Even if it's a massive planet like the big ones, the really big ones.
Yeah, but see, my point is that Jupiter is so far away compared to the moon. Now?
Huge.
Well, it doesn't matter.
Bay of Fundy?
It's inversely proportional to the square of the distance. So every time you double the distance, its effect only is 1/4 as great. If you triple the distance, its effect is only 1/9 as great as it was before, you see.
And does the orbit affect anything in somehow?
The orbit of what?
The orbit of any planet, the swinging around, is that?
Well, those orbits are pretty well fixed ellipses, and they're very, very constant. They're not deviating. They're constant within, a millisecond. Our astronomers can predict the position of a planet, many orbits in advance with total precision. Now, that's not to say that something couldn't come along and upset that, and I'm going to get to that before tonight's talk is over. But in any case, let me conclude about this because I think it'll hopefully settle the issue of pole shift and how that fits into the whole scenario we've been talking about for the last couple of years. If you rapidly remove that load of ice, what happens now to the land beneath the ice that has been depressed down perhaps even a couple of thousand feet? It comes rising back up, doesn't it? As it rises, it's now moving away from Earth's center of mass by hundreds and perhaps even several thousand feet from where it was before, right? Now, if you have a landmass that raises by 2,000 feet, let's say, how far would that translate in? How far in latitude do you have to travel to get 2,000 feet closer to the center of the Earth or 2,000 feet farther away? See, that would be a measure of its latitudinal disequilibrium. There's now going to be a tendency for that land, like the North American craton is pushed down into the mantle, 2,000 feet, say. The ice is released, North America becomes riding back. It comes back 1,000 feet, let's say, and now it's 1,000 feet out of equilibrium because it's not at the latitude that would coincide with its distance from the Earth's center of mass. Are you following this? What is that going to create the tendency to want to do? It's going to want to migrate to a position, a latitudinal position that actually corresponds with its new distance from Earth's center of mass. And I think that's where Hapgood's theory now applies, because I think it's the loading and unloading of the glaciers from the glacial to interglacial transitions and back again that sets up these lateral movements of the Earth's crust. And then those lateral movements in turn can cause the buckling that lifts mountains, or the downfaulting that creates synclines and rift zones. And then, of course, you put on top of that the possibility of great impacts as well. And I think there with those two mechanisms, because right now, all of the ideas of the geophysicists for what causes continental drift is coming all inside the Earth. And I'm saying, yeah, there's probably is an internal component, but there's also an external component that's being neglected. And that can be, in fact, there was a book written in 1966 by a French mathematician, and it was called Bombarded Earth. And he came up with the theory that dislocations of the Earth's crust could be triggered by large impacts. And it makes perfect sense. Now notice on here, you do see that there are some islands in the mid-Atlantic, don't you? Did anybody notice that? Right there? Well, that happens to be right where the Azores are. Now, that's not an accurate reconstruction. My new reconstruction of Atlantis, I think, is actually much more accurate. I just put that there sort of symbolically to show that I think that's very possible. Now, of course, the opposite effect is when the ice mass leaves here and goes back into the oceans, there's a compensatory reaction. As this is rising up and this weight is being released from here and being put back into the Atlantic, what is the Atlantic going to do in response? Go down. Exactly. Now, if there are islands in the middle of the Atlantic, they're going to be subjected to two things: a rapidly rising sea level and possibly a depressing sea bottom, which taken together could cause major submergence of land masses, particularly if they're along the mid-Atlantic ridge, one of the Earth's hinge zones, where the Earth's resistance is going to be very minimal compared to other places like where the thick continental crust is. There are those who would have the pretense of being scientific who would just completely and derisively dismiss the idea of Atlantis without ever having looked at the stories or actually looking at the geological evidence. And I've told you about that, how in the 1970s the geological community basically said Atlantis is a bunch of nonsense and Plato. There's no evidence that there could have been a large submerged landmass in the mid-Atlantic. That was the proclamation of the geological community. And all Atlantean researchers from that point on then begin to disperse to the four corners of the Earth to try to find Atlantis, because the geological authorities had declared that a mid-Atlantic site for Atlantis was ruled out. But even when they made that declaration, the evidence was mounting overwhelmingly that yes, there was a large sunken landmass in the middle of the Atlantic. And the evidence in the last 30 years has only confirmed that yes, there was or is a large submerged landmass in the mid-Atlantic. And it can clearly be explained by the transition from the glacial to the interglacial age, the rising of the sea level, and the isostatic adjustment of the Earth's crust. And what we see now is the Azores are the tips of the great mountain ranges that were part of the Atlantean microcontinent. Okay, let's go on here.
Did you ever go up to the Bay of Fundy?
No.
Okay, thank you.
That's an experience. I started out walking out into the bay when the tide was clear out,
Mm-hmm.
and a guide come out on a motorcycle and said, you better not go any farther, because he said, when that comes back in, you can't outrun it.
Really?
Bay of Fundy, normally, if the tide is out, it's about 150 feet across. When the tide is in, it's almost 9 miles across.
Say that again. When the tide is out,
It's about 150 feet across.
the bay is.
Bay is.
The water is
That's
100.
right.
And when it comes
About
in,
9 miles across. It's the highest tide in the world.
that
57 feet.
How much?
57 feet.
wow.
It water goes up,
No.
up St. John's
The
River.
Bay of Fundy.
Right, crazy. Goes right straight through to St. John's. It pushes the St. John's River north when it comes in. Then the St. John River runs out. It does that twice a
They
day.
have some sort of a generating plant up there.
And it's an experience to watch that thing come in. You can't outrun it. It comes in that fast.
Did you try, Sam?
No, I got about, probably 500 yards out into it. And this guy come out on a motorcycle and said, get back out there because it'll come in. And before I got to shore,
It was coming in, huh?
it was coming in.
Sounds like a field trip to me. Well, you know, there's some other stuff up there, right up in that area, that would be really cool to see.
It's the Bay of Fundy.
Manicouagan. You know, we're going to do a canoe trip, right? Who's up for a canoe trip around the ring lake of Manicouagan? You don't? Here, this is it. That's not far from what Sam was talking about.
That'd be a big explosion.
This right here actually is where the rim of the thing is out here. And this is the central uplift. And this is 50 miles across from here to here. Or maybe a little less. So it's probably 120 miles around. So that'd be about a week-long canoe trip.
That would be interesting.
Speedboat?
Get a horse.
Yeah, but that's up in, that's in Ontario. No, it's in Quebec. It's in Quebec. Yeah.
Where's Oak Island?
Where's what?
Oak.
Oak Island is probably not going to be visible at this scale, but it's going to be right along in here somewhere on Nova Scotia, right down in here. Did you hear what she asked?
The Bay of Fundy just north of there.
Yep, Sam, this is the Bay of Fundy here, isn't it?
Yep.
Yeah. Can you see this right here? Yeah, there it is, right there. Now it's, look at this. A probable, not a proven, but a probable.
That's pretty random.
Now that's called the Nastapoka Arc. It's part of Hudson Bay, and actually, the lake there occupies. It's called a downfaulted graben. The central part rises up, and then outside that there's a ring section that drops down, and so that's now occupied by a lake. And now also look at this. This is almost certainly the. In fact, about a year ago, somebody actually came up with some evidence that this is Prince Edward Island. So this is Nova Scotia, and this is Prince Edward Island, and this would be Newfoundland.
So what's the ratio between all three of those circles? They're almost like in a line.
Well, since you asked,